Okay, we're going to try a little bit more of the devil's calculator. Oh, that's interesting. Interesting. So, 0, 0 isn't defined. Not defined. What about 0, 1? Okay, what about 1, 0? Okay. So, 1, 0, not defined. So I have made a table, a two-dimensional table. Down here are the x values that we input into our function. Right here there are the y values that we input into our function. And this right here is the output of the proper inputs x and y. So I'm expecting this to be like that. And this line to continue, well, not like that, to continue like that. Does that work? Ah, what a pity. Not quite. But I think it will be like that. So currently the expectation is going to be if we take, for example, 13. Is this correct? No, this is 12, 11. Okay, good to know. I need to remember. So 11 at 8. Then I'm expecting 11 over 8. Or if I just... let me quickly think about this. So if this gives out a 0, this means this is x over y. So yeah, 11 over 8. So 11, 8, 3. Uh-oh, this doesn't look like 11 over 8. Well, let's wait with the correct answer a little bit. Also, 3 seems to be exactly the difference between 11 and 8. Well, we'll wait with our judgment a little bit. Also, why is this a little... whatever, okay, 1, 1. Is a 0, okay. Okay, let's go for 2, 1. Also 0. 3, 1. 0. 41. 0. Okay. Okay. Let's check out the 2's. 0, 2. Okay. 1, 2 is a 1. 2 is a 0. 3, 2 is a 1. 4, 2 is a 0. Okay, this should be a 1 and this should be a 0. So let's just say we expand this a little bit. No, like this. 1. Okay, they can't do that. Okay. So 0, 1. Okay, we're going to do this the following way. Equals. This is the one where we are at 10. How do we do this the best way? 1 plus this equals 1 plus minus 1 to the power of this minus 2. Nah, I can just keep this away. Error, okay. Do we have a function that can do this? I would like to do exactly what is standing there, and then we divide that by 2. 1 second, I will check whether we have such a function. Okay, I had to tweak a little bit with I first of all I selected the entire row instead of one single cell. This was one of the mistakes I made, and second of all I just tweaked a little bit with the formula, and this seems like an appropriate formula to me. Now we can expand this. Okay, and I still have this from the last video I did. And now I would expect this to happen. Hello? Okay. 0, 0, 1, 1, 0, 0, 1, 1. At least that's the first expectation that I had. So first of all, we're going to check this out. Let's check out 25 and 2. 25, 2 is a 1. 28 and 2 is a 0. It fits, okay. Next, let's check out 1, 3. 1, okay. 2, 3. 2. Okay, 1, 2, 0, 1, 2. This looks like a modular operating system. So 2 modular 3 is 2, and let's say 16 mod 3 would equal 1. But we can't input that, so let's say 17 mod 3 would equal 2. If this is what we're going for. 17 mod 3 equal 2. Okay, yeah. This makes things a lot easier. Modular is more understandable than the last one. So how about we go for 700 as the smallest number which we can take as our modular operator, which we can input into our modular operator to even be able to input 666 without using the number 6. I think that this is the smallest number. So we are going to do this right here. Delete, and right here we're going to write in 1, 2, select. I don't even need to do this. I can just equals 1. Hello? Can I expand this? I do want to expand this. Okay, that doesn't work. Okay. Okay, whatever, I'll do this the old-fashioned way. I'll just expand this. Okay. 1 second. So, 1, 2, 3, select, and expand until I have at least a decent number. Let's say 1000 probably. I think there's a more efficient way than doing this, but this is the one where I don't have to use any brain cells. I just input this and get the result that I want to. I could even seriously, there's a lot easier a method to do this. Equals this mod 700. Okay, it doesn't work. Equals mod of this and 700. 2. Okay, and I will copy this right here. Right here, I will change this to Q1. And now we're expanding until the entire row is finished. Okay, now it works. Thank you. Thank you very... What? Okay, yeah, correct. So, do we have a 666 lying around? Right here, but we can't use that one. Do we have another 666 lying around? This one worked, but the other one doesn't. If I increase this one, yeah, okay, so I need to do this one first, and I don't know how to do this automatically. In the meantime, while I'm doing this, I'm thinking about a better way which would be a little easier and faster than the one I'm doing right now. So, well, it's almost finished. Let's just check if there's an easy number we can use, and then we can still do this in a different way. 1 second, please. Right here, there we are. 1 second. Okay, we're going to do this a different way because this would take a lot too long. So let's just go with the following. First of all, because I think know everything we need to know, we are going to delete everything. Then we're going to go over here. We are going to write this as equals 666 times this space right here. This one we're going to call 1. We will expand this to right about here. We will expand this to right about here. And now we are going to say this equals mod of this and 766. And we are going to expand this right here. Okay, so which one do we want? So we need one single one. Yeah, no, I don't know. I think I made it. 1 second, I need to think this over again once more. Okay, and if I'm correct, I will explain what I'm doing right now after I tried this one out. Okay, this was a lot easier than what I thought I had to do. So basically what I did was I wrote a function 666 plus 700 times a multiple of 700 right here. Those are all the numbers which if modded by 700. So if you input this and then 700 into the function, then you will get 666. If you input this and 701 into the function, you will get 666, and so on. I just looked for the first number I saw, which I could input under those criteria. That's all. There was nothing special or hard about this. I just I don't know why I made this so hard on myself. How long have we been here? You know what? I'm going to make this one a little. You know what? We're going to try this a little bit. We're going to try this a little bit. But I do need to be a little quicker. So, first of all, delete, then black, okay, then expand, let's say 12 should be enough, expand, let's say 12, let's say 39 should be enough, so 001, 012, 9, and 03 is 28. I can't yet see any resemblance of a pattern here, so 05, 126. Okay, let's continue for now. 1, 0, 2, 2, 0, 9. This should be a 28, this should be a 65, this should be a 126. So a 5, 0 should be 126. So do we see anything which we can utilize here? This is an increase of 1, this is an increase of 8, this is an increase of 3, and then we add 1. This is an increase of basically 2, and then we add 11. This is an increase of 2, and when we subtract 4, no, this doesn't fit at all. So I don't yet see any pattern. So let's continue with 1 1. This would be a 3. Let's continue with 1 2. This would be a 10. 1 3. 29. Okay, this should be a 66. 1 4 should be a 66. This should be a 127. I think this thing is symmetric, so once more 29. Right here 66, 127. Correct. 7 and 1. No. 1 and 7. 1 and 6. 1 and 5. Yeah, okay, yeah, okay, everything's correct. I don't know why. This is a 7, but this is a 5, so I made a small mistake with that. Whatever. So if we increase our... Okay, so let me think about this once more. So 0 and 2 would be a, let's say 0 and 4 would be a 65. 1 and 4 would be a 66. So let's just say, just hypothetically, 667 and 4 is way too big. Okay. So what should we do? Okay, yeah, I noticed why. Okay, so if we go right here, we should be getting a 67 at 4 4. No, it's a 129. Okay, yeah, I still have a little bit of a problem with that. Whatever, 129 should be a 4 4, right? Yeah. What about a 4 3? 92. Did I skip something? Okay. Yeah, no, I think this would take a little too long. They don't really have that much time left. So maybe we will continue this one another day. Since we already did one puzzle today, I think this should be fine. The last video was pretty long, so I'd say we will see each other later. So goodbye.